In the previous example, we saw how we can animate the rotation by overriding the update method and change the angle with some portion inside the update method. And since we can change the angle continuously or simultaneously like an animation, we can also change the position of any component. And in real game, we could have some players, some enemies, and we need to move our players top, bottom, left, right, etc., etc. So let me do something like that. I'm going to put only the rectangle component. I'm not going to use this my position component right now. So what I'm going to do is I am going to remove inside my flamegame.dart file. I am going to disable this line also, and then I am going to add my rectangle component, and I want it at the center of the screen, so that would be size divided by 2, and the size of the rectangle could be vector 2. The x could be like 50 and the height could be 150. So this is not a perfect square. The width is 50 and the height is 150, like a portrait scene. So if I now hit enter or restart the application, then we see our rectangle component, but it's still rotating. So we should stop the rotation. So I'm going to remove this line from the update method. Okay. So now what if I want this component to move across the screen, or what if I want this component to move along the x-axis to the right or left or top or bottom? So we need to do the same thing that we did for changing the angle. So we need to do something in the update method. So for my rectangle components, inside the rectangle component inside the update method, what I'm going to do is, let's say we will only move this component to the positive x, only to the right direction, to the east. So we can say position, that means the position of this my rectangle component, and the position dot x, and we want to add some value to this x, maybe like 100. If I put 100, that means the position of this my rectangle component will be changed by 100 unit. I mean, we are changing the x value of this rectangle by 100 per frame change. So if I now restart this application, you will see that we can see nothing. I mean, our rectangle component just vanished. It moved so fast to the right because it is actually moving 100 per unit. I mean, per frame change. And this method is called 60 times per second. So that's why we need to add some like multiplier to reduce the speed, and we can actually add the delta time. We know that the delta time is very low. I mean 0.01, something like that. So if I now restart the app, and now you see that our component is actually moving along the positive x at speed 100. I mean, we are not 100 actually. So per frame, it is moving 100 divided by this dt. Okay. So now our component is out of the screen, and in real scenarios, maybe we should bounce back the component when it reaches the edge of the screen. That's a different story. We will deal this kind of situation when we learn about collision detection and so, okay. So now it is only the x direction. What if I want to change also in the y direction also? Okay, so I'm duplicating this line and I am going to change the y axis or y value as well. So now it will go in the bottom right corner. So the position is updating in per frame change to the positive x axis and also in the positive y axis. We can reduce the speed by some degree. For example, let's say it is 40 and let's say it is 40, and now if I hit restart, then you see the movement is now quite low. So in this way, we can actually move our component anywhere on the screen along the x-axis or y-axis or positive x or positive y. But we can actually simplify these two equations and turn it into one equation. So whenever we try to move something on the screen, we can represent the movement by terms of velocity. So velocity means the magnitude and also the direction. That means the change in both x and y axis and also the direction. So in most cases, whenever we want to move something on the screen, we introduce a special vector called the velocity vector. So what I'm going to do is I'm going to now declare a vector inside my rectangle component. Let's say final vector 2, let's say velocity, and the velocity is, let's say, vector 2, let's say 1 and 1, and it looks like a unit vector. Okay, so it looks like an unit vector. So instead of increasing the x value and y value of the position of this rectangle component separately, what we can do is we can simply say position. So this is also a vector, and we will try to add another vector, I mean this velocity vector. And after a vector, we can say, or we can call a method called add. And now we say the velocity vector, which is 1 by 1. So it will move 1 unit per on the x-axis and 1 positive on the y-axis and multiplied by dt. And if I do so, if I now run this application, and I think you may notice nothing, but if you look very carefully, it is actually moving, and the movement is very low because per frame change, it is actually moving just 1 unit in both axes. So in that case, we can add like a scalar value, like a speed. So we can define a speed. In most cases, in games, we define the velocity and also the speed. So let's say the final double speed, which is say 50. So what we can do is we can add the velocity, and we are multiplying with dt, and also we can multiply with the speed. Okay, so now you see the movement quite a bit faster. So it is moving with the speed 50 for per frame change, not actually 50. We have to divide the dt. We have to divide the speed by dt. So whatever amount we get, that is the speed per frame change. Okay, so this is how we define a velocity and a speed whenever we want to move a component across the screen. And this is super useful whenever we create a game and we have a player or enemy or any object or game object that should move across the screen. The first thing we do is we introduce the velocity, and also we introduce some speed. And the benefit of taking the unit vector, that means 1 and 1, is that we are not actually interested in the magnitude or the value. We are only interested in the direction. So 1 by 1 means, I mean x1 and y1 means it will always go diagonally, okay, in the bottom right corner. So we are just interested in direction, not actually the magnitude or the value.